In the following video, we're going to go over examples on how to determine if a relation is a function and then define the domain, define the range. So we're given in the first example a set of coordinates 3, 5, 2, 1, 3, 2, and 4, 1. So when we want to first determine if this relation is a function, what we're going to do is we're going to plot the points. So we plot the point 3, 5, the point 2, 1, the point 3, 2, and the point 4, 1. So after you plot these points, to determine if this relation is a function, we have to see, does it pass the vertical line test? And remember, the vertical line test says that if you were to draw a vertical line anywhere through the relation, if it intersects more than once, it's not a function. So let's try it. I'm going to draw my vertical line, and it's easy to see this way. And if I were to draw it anywhere through this relation, do we ever see it intersect at any point more than once? So if I go back, we see it intersects once, but at this point, at this place on the relation, we see there are two intersections, one at 3, 5 and one at 3, 2. So since there are two intersections when we draw a vertical line graph, that means this is not a function. So not a function because it intersects more than once when a vertical line is drawn to the graph. But we can still state our domain and we can still state our range. Our domain represents the x values. So in stating the domain, we're going to put them in braces. And then you look at the x values. We have a 3, we have a 2, we have a 3, we have a 4. So when you state the domain, you put it in numerical order. So 2, 3, 4. When staying in the range, you do the same thing. We have a 5, a 1, a 2, a 1. So we put them in numerical order. We have 1, 2, 5. So the domain of the relation is 2, 3, 4. Those are my x values put in numerical order. And the range of the relation is 1, 2, 5. And those are your y values. So let's try the same idea in the second example. Negative 2, 1, we plot a point. 1, 3, we plot a point. 2, 5, we plot a point. And 0, 5, we plot a point. So again, to determine if this relation is a function, we're going to have to try and see if it passes the vertical line test. So when I'm doing the vertical line test, I sketch a vertical line and I try and see if it matters where I sketch it, does it ever intersect more than once? So I slide it over, it intersects once, continue, one intersection, and one intersection. So this will always only intersect the relation once, which means that this relation does represent a function. And same idea, we can state our domain and range from here. Our domain is the set of x values in numerical order. So x is negative 2, 1, 2, and 0. So numerical order would be negative 2, 0, 1, and 2. My range represents the y values in numerical order 1, 3, 5, and 5. So that'd be 1, 3, and 5. So that is how you determine it from a relation, a set of ordered pairs, or even a graph, if the relation is a function, and how you state the domain, the x values in numerical order, the range, the y values in numerical order.